Hello again, physics students. We will be covering some notes now on graphing relationships. The opportunity here is to extend our understanding and our method of communicating change through mathematical graphing on Cartesian coordinates. And it basically relates to three different types of functions. All right, we have seen extensively in our first couple of weeks the linear function, so that will be our starting point. Here we see the three types that we will specifically address: linear, also known as direct relationship, quadratic, and the inverse. These are the three types of functions that we will work with extensively in our physics classroom. The linear should be quite familiar to you by this point. We have seen it in our ballistic car exercise and in the how far around exercise. Both opportunities to extend our measurement skills, but also to see how error affects measurements and to observe, when properly performed, the effectiveness of the linear graph. It produces a straight line through the origin relationship. The SLTTO acronym reflects straight line through the origin and is your mnemonic for remembering this relationship. These relationships, that is, will be summarized at the end of the lecture notes, and you'll have an opportunity to copy the chart that will simplify this information. All right, at this point, it's just expected that you will understand that there are three different types, and here we see linear as our first type. In this relationship, x increases as the y increases, or x decreases as the y decreases. They often will react in the same direction. Here we see an example of this relationship. This is a graph of John's savings account balance for the year. Here we see the y-intercept for this relationship is 300. So the y equals mx plus b is the equation for this line, with b equals 300. And if the slope is 100. For every unit that is changed on the x-axis, the y-axis increases by 100. So the equation, the actual equation for this line, becomes y equals 100x plus 300. This is the linear relationship. Another type is the quadratic relationship. It produces a parabolic curve due to x increasing in equal increments, while the y increases in a squared fashion. You will find that this relationship is described in your text as y equals ax squared plus bx plus c. Recall that as in the linear, when there is no y-intercept, or the intercept point is the origin, the value for the intercept is 0. Here we see the parabolic curve that would result from a quadratic relationship. I will remind you that we will use the trick of pairing P and Q. So parabolic goes with quadratic. And then our final relationship is the inverse, in which we have a hyperbolic curve due to one variable increasing while the other variable decreases. The equation for this relationship is y equals a over x, or you can think of it as y equals 1 over x. We've discussed the concept of the football analogy, where the ball is on the 10-yard line first and goal from the 10-yard line, and there's a penalty, and they say half the distance to the goal. Each penalty takes you half the distance closer, but as you are halving the value, the distance between you and the goal line, in the football analogy, you will never actually reach zero. We see that described here in this graph. Notice that as the x value is increasing, the y value is growing closer and closer to the origin. Here we see the x value increasing and the y value, if you reflect on where it would be, is slowly getting less. So when x is 10, y is 1. When x is 11, perhaps 0.95. And this value will continue on in an asymptotic nature all the way to infinity. This is the third and final type of relationship. So the three significant relationships are linear, quadratic, and inverse. Linear is the straight line through the origin, quadratic shows the parabolic curve, and the inverse shows the hyperbolic or hyperbola. Again, for memorization purposes, Q of quadratic will be paired with P of parabola, and H and I, as in their alphabetic A, B, C, D, E, F, G, H and I go together, so I for inverse is paired with H for hyperbola. We will use these relationships extensively as we attempt to represent real-world motion with mathematics and graphing. It will be expected that you will be able to recall which relationship you're observing simply by graphing data points that you have collected. We will see this in several of our labs. Hopefully this has given you an opportunity to copy this chart as it summarizes in a very succinct manner all the information that we need for this portion of our physics lesson. Hopefully this is now at this point review and reinforcement of the concepts we have discussed in class. Thank you.